video on chapter 19, and it's all about fossil fuels. So the chapter starts with a case study about Alberta's oil sands and the Keystone Pipeline. It's an important case study because there is some controversy related to it. Basically what happens is they remove sands, which has oil embedded in it, from Canada, and they actually send the sand to Texas. All right. And the reason why they do this is that it's actually cheaper for them to have built this pipeline from Canada to Texas than to potentially build new refineries in the northern states like Montana. Also, there's a potential that the Clean Air Act wouldn't even allow the new refineries to be built because of all the regulations. So they just decided to bypass that and build the pipeline. Oil sands are also known as tar sands, and they're deposits of moist sand and clay, and they contain bitumen, and that's a very thick and heavy form of petroleum. They remove this by using strip mining, or they use chemicals that liquefy it. And this process has a huge environmental impact. It degrades the environment a lot. So there's a lot of people against it, as you can see here. Okay, so on the next page, it shows you a picture of the Keystone Pipeline. As you can see here, all the way in Canada, and this is the current, and then there was a proposed one. There's a lot of lawsuits that we're facing, mostly due to the habitat loss, potential spills, and health issues. In 2015, President Obama actually decided against adding this extension, and due to the fact that he felt that it would not serve the national interests of the United States enough. So as of now, it is not going to happen, but things can always change if it's brought up again. Moving on to the next page. This chart here, you need to make sure that you know all the different energy sources, which are considered renewable and non-renewable, and it gives a little description of exactly how we obtain it. Big thing you have to make sure you know is that most energy comes from the sun in one way or another. So for example, fossil fuels is made up of once living things. So they all were dependent on the sun for energy at one point. Solar, which is obviously from the sun. Wind. The sun actually helps create convection currents, which creates the winds over our oceans. Hydrothermal, these are from dams, and the water cycle wouldn't happen if it wasn't for evaporation and transpiration, so the sun plays a role in that. Biomass. Again, photosynthesis plays a large role, which requires the sun, and it helps grow all the different products that make up biomass that we burn. And then the last type is wave energy, and this is an indirect relationship with the sun, and that's because the wind, which is caused by the convection currents, is what actually causes wave energy. All right. The next one, you have a map here. And the big thing you need to know is that the USA uses the most energy, is the most energy intensive country. All right, we use the most per capita, followed with Canada, Norway, and Saudi Arabia. So we are the top 4 in terms of who uses the most energy. So you can see the numbers there. As you can see, we're all the red. Above it is a table that talks about the largest reserves. And this is something new that's popped up on the AP test the last couple of years. The United States actually has the largest world reserve percentage of coal. All right, and then for oil, it's actually Venezuela. They bypassed Saudi Arabia, and that's just because they've been extracting so much. And then natural gas, Iran, and then Russia. So just make sure you have an idea who the top, at least the top one is, if not the top 2, for coal, oil, and natural gas in terms of reserves. All right, so what are fossil fuels? They're organic material broken down in anaerobic conditions, and they undergo heat, pressure, and time. It should sound very similar to your metamorphic rocks that we learned about earlier this year. So if you go to the next page, there's 2 ways that fossil fuels can form. Big thing here, as they show you, you have originally woody a forest. Eventually all the vegetation dies and falls into a swamp. It undergoes heat and pressure and anaerobic conditions, and eventually you get coal in the present day. All right. You can also get natural gas in a similar way, where you have your plankton your zooplankton, your phytoplankton, and other marine organisms that die. They eventually sink to the sea floor, get piled on top with sediments, again, undergo heat and pressure deep underground, and then they form your natural gas. All right. Big thing to remember is coal is basically from an ancient forest, and natural gas is from ancient ocean plankton. Next image shows you the life cycle and different types of coal, so make sure that you review this. Peat is basically the precursor for coal, and it's actually used in Britain a lot for heating and cooking. Okay. Anthracite. This is the best, which is your one down here, in terms of energy per volume, and it creates the least amount of air pollution. Now, bituminous coal is the most common in the United States, and it contains high amounts of sulfur. Okay, so just make sure you understand as it increases with pressure which ones they are. Other things you need to know is oil share, which is kerogen. And this basically is when the rocks break up from fracking, and we actually have to use a lot of water in order to get the oil shale from there. And then the last other type is methane hydrate, which is what we get from ice. All right, this little behind the story talks about the different ways that we search for fossil fuels. And the two ways we do it is we either drill rock cores or we use seismic surveys. So if you look at this diagram, it shows that. So we actually send seismic rays down into the ground, it refracts back, and that's how we know where we should be drilling for different fossil fuels. And it all goes with the times of the densities, the thickness, and the type of rock. It will have all different rates in which they kick back. All right. It also talks about the 1002 area in Alaska. Okay, so we have Nitro Reserve, we have this purple region, and then we have this green region. And your 1002 areas is very, very top part of the green. And the United States Congress has actually put that aside, is that we could potentially drill there. And it's part of the Arctic National Wildlife Refuge, or ANWR. And basically they always put it on the back burner that we could potentially drill it. And this topic comes up every few years, usually around election time. Should we or should we not drill in this 1002 area? The Arctic National Wildlife Refuge is the most preserved as wilderness. And again, Congress is the one who gets to decide if we should open it for drilling. So the pros to drilling in this area: it could be good for economic development, jobs, and it also can reduce our reliance on foreign oil, which has been an issue whenever we are in war, and that's when you can see oil prices drastically increase. For those that are anti-drilling in this 1002 area, this location is essential habitat for migrating caribou, birds, and other species. The Inuits, which is the local native people of this area, they actually rely heavily on the caribou that live there. So they're 100% against it. And this is one of the few remaining wild places. And contrary to what a lot of people believe, if we were to drill and destroy this part of this natural habitat, it actually would only decrease our gasoline prices by 1 or 2 cents per gallon. So it's not really a significant change that we would see if we drilled in on our own property. Okay. This figure here talks about how oil sands are extracted. And there's 2 different processes. There's strip mining or stream extraction. And this is what we use for a lot of oil sands. And needless to say, these are not very environmentally friendly. But just make sure you review and go over these. We'll talk more about strip mining when we get into our mining unit, which is chapter 22. All right. So crude oil is refined into different products by distilling it, and every single one has a different type of boiling point. So you can think of the crude oil as the raw material, and then we can distill it to create all these different types. All right, so fuel oil will have a boiling point of 370 degrees Celsius. You have your diesel, your kerosene, your gasoline, and so forth. So just make sure you realize that crude oil is the original, and then we have all different types. But they all, at the end of the day, are considered a type of oil or petroleum. Okay. All right. So electricity is generated in multiple steps. First, fuel such as coal is burned. Then it heats and causes water to boil. Then steam is forced through pipes, which creates pressure. And the pressure eventually spins turbines, which causes electrons to move within the generators. And then these electrons, which basically is the electricity, is sent to the public through wires. So that's roughly how your whole electricity system works. As you look at this figure down here, this is all about a coal-fire powered plant. Okay. So just review the steps. Big thing is, notice in over here, number 6, we have pollutants from combustion that we filter them, but then they're released still into the air. And then the big question is, what do we do with the toxic coal ash? Where should we send it? Right now it goes to hazardous waste landfills, but what could we do? Because eventually those will fill up. Okay. Next image, this table over here talks about the top extractors and consumers of oil, coal, and natural gas. Make sure you know the top 2 in each category. As you can see, United States is the top consumer and extractor in both oil and natural gas. China beats us though in coal. So just compare and make sure you have this idea here. Okay. The figure below is really important. You know, we always assume petroleum is just for fuel, but we actually use petroleum for a lot of everyday items that are not necessary. So this image shows you pretty much everything that you could find in your home that is made out of petroleum in one way or another. Specifically your plastics. We can use other materials to make plastic, however, we use petroleum. But again, the number 1 use of petroleum is for transportation, but we use it in a lot of everyday items, including plastics, your television, certain fabrics like polyester or nylon, on your toothbrush, etc., etc. So just make sure you review that. Okay. The next section we talk about is peak oil and what it is. And there's these two diagrams you should review. All right, you should know what peak oil and the Hubert's peak is. Yes, are we running out of oil? We're going to. Are we within our lifetime? Probably not. But right now, the peak oil is basically the easy accessible. And Hubert actually predicted when we were going to be in the peak amount pretty well. Okay, we are now get all of our oil from deeper in the ground, and that makes it a lot harder to get. So over time in our future, yes, we will still have oil. We're not going to run out. However, oil will continue to get more and more expensive just because the process will take longer because we have to drill so much deeper in order to obtain the oil that we have. So just keep that all in mind. Okay, we are going to stop here and pick up in the next video.